Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Greyscale, and it's by Blue Toast 1. And here are the rules. We have normal Sudoku rules apply, which is put the digits 1 through 9 in every row, column, and 3 by 3 box. Excuse me. We have black crop key, where digits separated by a black dot indicate one digit is double the other, and not all possible dots are shown. We have white crop key, where digits separated by a white dot are consecutive and not all possible dots are shown. So as examples, if we had, say, a 2 here, this would have to be 1 or 4 to maintain the 1 to 2 ratio between them. If this digit were, say, a 6, this would have to be 5 or 7, because these digits must be consecutive, because there's a white dot between them. And those are examples of how crop key dots work. We have killer cages, where digits in killer cages sum to the number in the top left corner. And digits may not repeat within a cage. So, for example, if this were, say, a 8 here, this would have to be a 5, because these two digits must add up to 13, because they are in a killer cage, which has a 13 in the upper left-hand corner. We also have 4 different line types. One is a German whisper line, where digits on a green line must differ by at least 5 from adjacent digits. We have a Renban line, where digits on a pink line must be a string of consecutive digits. A string? That's kind of weird. That's a weird way of putting it. And these digits can be placed in any order. Also, you cannot have repeats on a Renban normally. I'm pretty sure that that's also continued here. We have entropic, where any set of 3 consecutive cells along a peach entropic line contains one low digit, which is 1 through 3, one medium digit, which is 4 through 6, and one high digit, which is 7 through 9. And we have a parity line, where adjacent digits along the red parity line must alternate between odd and even. But wait, I forgot to bring my paint. You're going to have to figure out which line is which. There is exactly one of each. I'm sorry, I promise this won't happen again. So as examples, say this was the Renban line. Then these digits would have to form a set of consecutive digits in any order. And they would have to be 1 through 9 here, if that were the case. Because there are 9 cells on this Renban line, and you can't have repeats, so there must be just 1 through 9. So that's an example of how Renban lines work. On entropic lines, any set of 3 consecutive digits on an entropic line contains one low digit, one medium digit, and one high digit. So if this were the entropic line, you could have something like, say, 3, 4, and 9 here. And this would be valid for this portion of it, at least, because for these 3 adjacent cells, or consecutive cells on this line, we have one low digit, the 3, one medium digit, the 4, and one high digit, the 9. So that's an example of how an entropic line would work. Let's do German whisper. If this were a German whisper line, this would be, and this were 3, this would have to be in 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And finally, on a parity line, if this were 3, this would have to be essentially an even digit, which is 2, 4, 6, or 8. So, those are examples of all the different lines, and those are the rules. Good luck. And if you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. These digits are in a 1 to 2 ratio with 2 unique digits. And the only digits that can be in a 1 to 2 ratio with 2 unique digits are 2 and 4. Also, these digits add up to 5, so it's 1 through 4 here. These digits add up to 17 with 2 of them, so it's 8 and 9 specifically. This is also 8 and 9 because of they add up to 17. 3 digits adding up to 6 is 1, 2, and 3 guaranteed. 2 digits adding up to 13 are either 4, 9, 5, 8, or 6, 7. But 5, 7, and 9 can never be next to a black Kropke dot. Because if you have 5, 7, or 9, you get 2.5, 3.5, and 4.5. If you double 5, 7, or 9, you get 10, 14, or 18, none of which are normal digits. So this cannot be 5, 7, or 9 here, which means this is 4, 6, 8. That means this eliminates 4, 6, and 8 here, because if this were 4, 6, or 8, 5, 7, or 9 would have to be there to compensate. 2 and 4 is consecutive with 1, 3, or 5. But if this were 1, this would be 2, but 2 would be in a 1 to 2 ratio with 1 and 4. So this can never be 1 here. If this is 2, this is 1, 4 as a pair. This is 4, this is 2, 8 as a pair there. And it's the same with this. This could be 1, 2, 4, 8. And we know for these sets of digits, if we have a 2 here, this is 1 and 4, so we're guaranteed a 4 in one of these cells. If we have a 4 here, this is 2 and 8 as a pair, which means we must have in these cells, which have a 1 to 2 ratio with 2 other cells, you have to have a 2 or a 4 there in those boxes or rows. So this cannot be 2 here, which means we have to have a 2 here. Where's the 2 in row 8 then? Actually, where is the 4 in row 8? Where's the 4, sorry, in row... What are the remaining digits? Let's do that. Remaining digits in row 9 have to be 4 through 9. And 4 cannot be here because of the 4 has to be guaranteed on either the digit that's in a 1-2 ratio with the other digits, with the 2 other unique digits, or it's one of the other 2 unique digits. So we're guaranteed a 4 has to be one of these 3 digits here. Otherwise, where's the 2? 2, where's 2 in row 8? Cannot be here because of the 2 guaranteed on the black Kropke dots here. Cannot be here because of the 1, 2, 3 triplet, and the 2 having to be one of these 2 digits here. So 2 has to be one of these 3 digits here. So this is either 2 and 1 in a 1 to 2 ratio, or 3 and 6 in a 1 to 2 ratio. Okay. These are in a 1 to 2 ratio with this. If this is 4, this could be 2 and 8, but this can't be 8 because of the 8, 9 pair in the column. Actually, let's do the remaining digits in column 7. Sorry, column 6. It's 1 through 7. Again, 5 and 7 can never be next to a black Kropke dot, so this can't be 5, 7, and that can't be 5, 7. This can't be 1, because if this is 1, that would have to be 2 there. What else do we have here? 4 can be next to 2. 6 can be next to 3. This can't be 6 because 6 would have to force a 3 there. So 4 and 2, 6 and 3, and 8 and 4 are all possibilities. 2 can be in a 1 to 2 ratio with 1 and 4. 3 can only be in a 1 to 2 ratio with 6. And 4 can be in a 1 to 2 ratio with 2 there. Okay. This can't be 2 or 4 because of the 2, 4 eliminated by 2 or 4 having to be one of these 3 digits in row 7. So this even digit has to be 6 or 8 here, guaranteed. These 2 digits are consecutive. You're always going to have one odd and one even, and the even digit cannot be 2 or 4. So then you cannot have 1 here. We can't have 3 here. So we could have 5 and 6, 6 and 5 and 7, or 7 and 8 as possibilities there. Interesting. Okay. How long are each line? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that can't be the Renban. This is much greater than 9, so that can't be the Renban. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that could be Renban. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So that could be Renban. Okay. This cannot be German Whisper because these digits are not 5 apart from each other. It can't be entropic because these 3 digits do not contain a low, a middle, and a high digit. Can they be parity? They could be parity, though. We have an 8-9 pair here. That eliminates 8 and 9 in the rest of the column, so this can't be 8 either. The rest of this box must be 1 through 7. And these are in a 1 to 2 ratio. If this is 1, this has to be 2. If this is 2, this is 1 or 4. If this is 4, this can't be 8, so it would have to be 2 here. So we're guaranteed one of these digits must be a 2. These 2 digits can never be 5 or more apart from each other. So this cannot be a Whisper 5 lines or German Whisper lines. I forgot to call it that. I called them German Whisper 5 lines instead of German Whisper lines. So this is either an entropic line or a parity line. Um, entropic line or parity line. Okay. So either every third digit is important, it's either the same set, because that's how entropic lines work, or every other line is important here. Let's try the every other line. So we'll make that green and we'll have pink and yellow. So pink and yellow, so that makes this yellow, that would make that pink, this yellow, this pink, this yellow, this pink. Pink, yellow, pink, yellow, pink, yellow, pink, yellow, pink, yellow, pink, yellow. This is pink. So these would have to be the same parity if they are a parity line. But To add up to an odd sum, you have to have an odd digit and an even digit to add up for the two digits. So this is not going to work as a parity line. So we don't have a Renban line. There are too many digits in them, so there's going to be a repeat. We can't have a German whisper line because these can't be more than 4 apart from each other because one is in a 1-to-2 ratio of the other. Therefore, this has to be the entropic line here. So let's start coloring then. Every third digit. So we'll make it yellow, pink, and orange here. That makes this yellow, pink, and orange. Yellow, pink, and orange. And then yellow and pink. So we have orange, pink, yellow, orange, pink. So these are both the same entropic set. And so it has to be a 2-3 pair here. So this is 2 and 3. That means this has to be 2 and 3 here. This is 1, 2 here. Cannot be 4, 8. This cannot be 1 or 2 here, so that's 4, 8 there. So we know one of these digits is a 2, so this cannot be 2 here, which means this can't be 1 to be in a 1-to-2 ratio. This can't be 1 or 2, it's a different parity, so it must be 4, 6. So yellows have to be 4, 5, or 6, medium digits, which means the orange has to be high. So the pinks are low. Yellows have to be green, medium, and oranges have to be high. So this must be 8, so we have to have 8 there. This is 4, that's 2, being a 1-to-2 ratio. That means this can't be 4 here. This can't be 8 here. We already have all the low digits and all the medium digits and all the high digits in row 3, so that leaves a low remaining in row 3, so that's a 1. 2 can be in a 1-to-2 ratio with 4, but this cannot be 8 here, so no 8 and 5 to add up to 13. This is a high digit here. This can't be 8 because of 8 in the column here. So this, as a even digit, this has to have a 6 here. Okay. Can this be a Whisper 5 line? I think the answer is no. It can't be Renban. This is entropic. So I don't think this can be a Whisper 5 line. If that were a Whisper 5 line, we'd have to have... 5 can never be on a Whisper 5 line. So therefore, what would that force this to be? That would force this to be 5. And... what would the remaining digits have to be? Well, we'd have to have... We only have 2 high digits remaining in this box, because we have 8 and 9 guaranteed here. But then we'd have to have 4 low digits here and 2 high digits. And we have to alternate between low and high digits on a Whisper 5 line, because you'll always alternate between low and high digits on a Whisper 5 line. If you want to learn why, go to one of my Learn How to Sudoku videos with Whisper 5 lines in it, and I'll explain. But this cannot be Whisper 5 then. So this must be parity lines here. Which means these have to be Renban or they have to be German Whisper 5 lines. Well, these can't be a Whisper 5 line, so this must then be a Renban line. And this is a parity line. So we'll color these different colors. I guess we'll mark it as pink and orange. That leaves this as pink and orange. 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 So we have 3 of each parity in box 4, and we have 8 and 9 here, which means this has to be an odd digit. So this is 1, 3, 5, or 7 there. This digit cannot be 1 or 2 because it's a Renban, and we already have 1, 2, 3 on the line. So the remaining digits here have to be 4 through 9 on this Renban. That leaves the where is so this digit here cannot be any of these digits on this Renban line because we can't have repeats. Can't be here, can't be on this Renban line, so it has to be one of these 2 digits, which means, and it can only be 4 there. So this is 4, which means this can't be 4 here. That means this can't be 4. It's 8, which is in 1:2 ratio with 4, which is in 1:2 ratio with 2. So no 2 here. It's 1 or 4. 8 eliminates 8 on the rest of this box. So this is 5, 6, 7, 9 as a quadruplet, which eliminates 5, 6, 7, 9 in the rest of the box. So this can't be 5, 6, 7, or 9. It's 1, 3. We have only odd digits remaining in row 7. So the pinks have to be odd, and the oranges have to be even. Therefore, this can't be 1. It's even, so that's 4. That leaves this as a 2, 6 pair. 4 eliminates 4 in the rest of the row. These are even. 4 and 6 is even. Um, 7 or 9 is odd. So this is 2, this is 4, and this is 8 and 9 here. So this even cell must be a 6, which eliminates 6 in the rest of the box. So this is also odd, which makes that even here, and that must be a 6. That means this can't be a 3, 6 pair. Therefore, this is 2 and 1 in a 1 and 2 ratio. 6 eliminates 6 in the rest of the row, so no 6 there. It's 5, 7, or 9. No more 6 remaining in box 9. So this is a Whisper 5 line here, and you'll always alternate between low digits and high digits on the Whisper 5 line. Again, if you want to know why, you can go to one of my Learn How to Sudoku videos with Whisper 5 lines on it. So this cannot be 5 here. We have 2 and 1 here. These are all high digits, which means this is a 7, 8, 9 triplet. That eliminates 7, 8, and 9 in the rest of the box. So no 7, 9 here, no 7, 8, 9 here. This becomes a 4, 5 pair. That leaves this as a 3. 4, 5 as a pair eliminates 4, 5 in the rest of the row. So no 5 here. It's 6, 7, 8, and 9 there. 1 eliminates 1 here, so that's 3, which means this can't be 3, that's 1. Which eliminates 1 in the rest of this line. It's 2, 3 as a pair. We have 1, 5, and 7 left here for the even digits. 4 eliminates 4 here, gives a 4 in the row. 4 is a medium digit here. 3 eliminates 3 here, so that's 5, which is a medium digit. So that leaves this as a 6. 6 eliminates 6 here. So that's 4, which is in a 1 to 2 ratio only with 2. That leaves this as 2 and is in a 1 to 2 ratio with 4. 4 and 9. Eliminates 9 in the rest of the row, so no 9 here. It's 8, which makes that 9. These 3 digits must add up to 12 without 2 and 4 available. So that eliminates 1, so we could have, and no 8. So you could have 1, 3, 8. You can't have 1, 3, 8 because of 8 in a row. No 1, 2, 9. No 1, 4, 7. 1, 5, 6 works. No 2 and no 4. So that eliminates 2, 3, 7, and 2, 4, 6, and 3, 4, 5. So this has to be 1, 5, and 6 to add up to 12, which means 1 can't be here and here because 1's in the columns. So 1's there. 6 can't be here or here because 6 is in the columns. So that's 6, which makes that a 5. That eliminates 1 and 5 in the rest of the row. This is pink. That's 3, 7 as a pair. That leaves this as a 1, 5 pair remaining in box 4. So this can't be 1 or 5. So where's 5 in box 7? It has to be here. This is a low digit. And it cannot be 4, it cannot be 2, cannot be 1. So this must be 3. 3 can only be next to 8 and 9 on a Whisper 5 line. This can't be 9 because of 9 in the row, so that's 8, which makes that 9. 8 eliminates 8 here. The remaining digits of column 8 are 7, 8, and 9, and this can't be 8 or 9 because of 8 or 9 in the box. So that's 7, which means this can't be 7. This is 8, 9 as a pair. Where's 2 in box 6? Cannot be here because of 2 in the column. So 2 is there. This 8, 9 pair eliminates 8 and 9 here, so that's 7. 2 eliminates 2 here, so it's 6 and 2. No more 2 or 4 here because of 2 or 4 in the box. No 7 or 6 here because of 6 or 7 in the row. 2 and 4 are here. This must be a 6, 8 pair. This can't be 8 because of 8 in the row. So that's 6, which makes that 8. Therefore, this must be 3 odd digits adding up to 15 because we have all the even digits accounted for in the central box. 2 eliminates 2 here, so that's 3 and 2. 3 eliminates 3 here, so it's 7 and 3. And this must be 3, 5, and 7 to add up to 15. So no 3 here, no 7 in either of these cases. This becomes a 3, 5 pair because of 7 in the row. That leaves this as 7, this as 1. No more 1 here. 7 eliminates 7 here, so it's 5, which is consecutive with 6. 5 eliminates 5 here, so it's 7 and 1. 5 eliminates 5 here, so it's 3 and 5. 5 eliminates 5 here, so it's 1 and 5. That leaves the remaining digit in row 5 as a 4. 4 eliminates 4 here, so it's 5 and 4. 2 eliminates 2 here, so it's 3 and 2. 7 eliminates 7 here, so it's 9. No more 9 there. 9 eliminates 9 here, so that's 8 and 9, which eliminates 9 there, so that's 8 and 9. This can't be 4, 5. It must be a 6, which leaves just 1 left in column 6. This is a low digit, so it cannot be 1 or 2. It must be 3. This can't be 2 or 3 because of 2 in the row and 3 in the box, so this is 1. 4 and 6 eliminate 4 and 6 here, so that's 5 as a middle digit. This is a high digit, cannot be 8 or 9, so that's 7. That leaves the remaining digit in column 4 as a 5. This is a middle digit, cannot be 5 or 6, so it's 4. That leaves in column 3 a 9. We have 2 and 6 remaining in row 1. This can't be 2 because of 2 in the column, so that's 6, which makes that 2. 6 eliminates 6 here, so it's 7 and 6. These are consecutive, so it's 7, 8 as a pair. We don't know which one. We have all the 1s, all the 2s. We have 8 3s. We know where the last 3 has to be. It's there. We have all the 4s. We have all the 5s. 6s. 1, 2, 3. 4, 5, 6, 7, 8, 9. So in 7, 7 can't be here because of 7 in the column, so 7 has to be here in the box. That gives us 8, 7, so the last 7 has to be there. 8 in column 2 has to be there. That gives us 8, 8, so the last 8 has to be there, which means 9 are the remaining digits. And that's a solution. Fairly straightforward. The lines were fairly easy to figure out, so it wasn't too bad. Yeah, and just pretty much straightforward throughout this puzzle. I don't think I even really needed this. So this one, that was interesting. This was actually kind of an extraneous rule here. I used everything else, though, in this puzzle to solve this, so everything else was kind of important. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.